So we are starting 4.3 proportional relationships today. This is our last notes before we move on to a quiz. So make sure that you pay attention today, get your homework done, so you are ready for that on Thursday. So to start off talking about proportional relationships, I thought it was good to watch a video over it. So this is just a refresher on what ratios are. I know that you've learned this before. This video does a really good job of explaining it and giving it a real world example of explaining it. So I'm going to turn on the closed captions so you can at least read what they're saying if the sound doesn't come through properly.
Math shorts. Proportional relationships. Two quantities are said to be directly proportional if they vary at the same rate. Meet Carl. He's mixing punch for a party. The recipe calls for 2 cups of juice for every cup of ginger ale. If he doubles his recipe, meaning he multiplies it by 2 to start with 4 cups of juice, he'll need 2 cups of ginger ale to keep the ratio of juice to ginger ale 2 to 1. If he triples his recipe, he'll need 3 cups of ginger ale. All the ratios of juice to ginger ale are equivalent. They all simplify to 2 to 1. This means that the relationship between the two quantities of juice and ginger ale are directly proportional. Another way to see proportions is with a graph. We can plot 2 cups of juice and 1 cup of ginger ale like this. We can show how Carl doubles and triples the original recipe like this. A straight line through the data points shows a direct proportional relationship as long as the line goes through the origin. But what happens when the line doesn't begin at the origin? Check out this graph. The line starts at 3 cups of ginger ale, so we would need to add 3 to all our previous answers on the table. But if we do that, the ratio of juice to ginger ale is no longer constant. The two quantities don't increase at the same rate. This is not direct proportionality, and Carl's punch won't taste so great. Ratios, tables, and graphs can help us identify proportional relationships and make awesome punch.
So hopefully that got you thinking about proportions, especially with that real life example. One thing that I wanted to point out is this table right here. So let's get back in focus. If we look at this table and we kind of think of these as x's and y's, this is when our x equals 0. What does our y equal at that time? That's 3, right? And that's when he said that this was not a proportion. It was 3 because we added 3. We added that constant. So we added 3 more cups of ginger ale, and it made the juice taste bad. So if it stayed at 0, that would be proportional, but since it changed to 3, it was not proportional. So keep that in mind when I'm talking about tables in the future. So 2 rules that you're going to ask yourself is the problem that Ms. Christie gave me a linear function? Linear function means that there's no exponents on the variables and no variables in the denominator. So if we look at these 4 problems here, let's see which ones we can cross out. So it has to be a linear function, which means there's no exponents on the variables and no variables in the denominator. So let's look at this first problem. Do you see an exponent on the variable? No. So do you see any variables in the denominator? So this one passes our first test. This problem here, is it a linear function? Does it have any exponents on the variables? Yeah, it does. So that goes away. It can't be proportional. Let's go to the next one. We have to have no exponents on the variables. Variables down here, I don't see an exponent, and no variables in the denominator. Well, the denominator is the bottom part of the fraction, so that's gone. It's okay if the exponent or the variables on the numerator, but it just can't be in the denominator. Let's check our last one. Is it a linear function? Any exponents? Nope. Denominator? Nope. That one passes our first test. Our second test is it has to cross the origin, which means it goes through the point 0, 0, just like how we were talking about in the video. In an equation, though, that means that there are no constants, so numbers without the variable. So if we look at this first one, I see a constant right here. That 7 is a constant because it doesn't have a variable on it. So that goes away. This bottom one, does it go through the origin? Is my b 0? Does it have any constants? No. So that is our proportional equation. If we think about how equations are written, we typically think of y equals mx plus b, because that's our slope-intercept form. Remember that m is our slope. So if we think back to the 4 equations that we just looked at, I know that this one was proportional and this one was not. This one technically has a plus b, but that plus b is 0. B is 0. So if we add on 0, we can kind of just get rid of that, because if we add 0 to anything, it's going to be itself. So when you're writing equations for these, because I'm going to ask you to, that b is kind of sort of gone because it's just a plus 0. So you just have to focus on this part of the equation for these problems, because that's what proportional relationships are. So let's look at this in graph form. First question we're asking ourselves is it linear? So is it a straight line? So I'm going to do problems B and E with you, and you're going to do the rest of them by yourself. So for B, it is linear. It is a straight line. Our second question is, does it go through the origin? Remember, the origin is where it's 0, 0, and it does not go through the origin. So we're going to actually write out a statement because we're answering this question, is it proportional? So if I asked you, is this proportional? You would say no, because it does not go through the origin. And that's our answer for this problem. If we look at problem E, our first question is it linear? Is it a straight line? You should say yes. And then the second part is asking us, does it go through the origin? And it does. It goes through the point 0, 0. So I know that this is a proportional relationship. Now it's asking us, if we answer yes, then we're going to be writing the equation. I figure out the equation because I figure out my slope. If you remember, we're just focusing on that first half of the equation because it's a proportional relationship. That b is 0 right there. So we're working on the equation y equals mx. M is our slope, so that's what we have to find. Slope is rise over run, so how much I'm going up and how much I'm going to go over. And it looks like I'm going up 1 and right 1 over and over again. So our slope, our m, is going to be 1 over 1, which simplifies to 1. So our equation is y equals, instead of writing an m, I'm writing a 1 and then keeping my x. We also know that 1 times anything is itself, so if I wanted to simplify this further, I could say y equals x. Both of those are correct answers that I would accept. So pause the video now, try these 4 problems, and I'll have your answers in a second. And here are your answers. So for A, you should have gotten no because it doesn't go through the origin. C and D are the same answers. F does go through the origin and it is a straight line. So now you have to calculate the slope. It's up 2 and over 1, which simplifies to 2. So our final equation should be y equals 2x. Now let's work on some tables. So our first question that we're asking ourselves is this a straight line? So you're going to look at the change in y and the change in x, just like how we do for slope. So this is going up by 2 each time. This is going up by 2. This is going up by 2. And this is going up by 2. So since it's going up by 2 every single time, I know that that y is good. Now we're going to check our x. This is going up by 3. 9 plus 3 is 12, so that works. 12 plus 3 is 15, so that's good. And 15 plus 3 is 18. So since x and y are going up by their same amount every single time, it doesn't have to be the same number. It could be different numbers like 3 and 2, but that x is going up by 3 every single time, and that y is going up by 2 every time, which is a good sign. The next thing that we have to do is we have to go back to find 0, 0. So I need to see if 0 and 0 meet up at the same point. So if I go backwards, I'm going to have to subtract 2. 4 minus 2 is 2. That's not 0. I have to go back another 1. So we're going to subtract 2 that time as well. And then I hit 0. So let's see what that x does. We're going to go backwards. So we're subtracting instead of adding 3. 6 minus 3 gives me 3. I have to subtract again because I'm not to 0 yet. So minus 3 gives me 0. 0 and 0 meet up at the same point. So I know that this is proportional because it passed my 2 tests. So since this is proportional, we're going to be writing an equation. So we have to figure out what our slope is, what m is. So to do that, I'm looking at the change in y over the change in x. I already figured that out. The change in y each time is 2. The change in x each time is 3. So my answer is going to be 2 over 3. Keep my x, and that's my equation. Let's move on to this next one. I'm looking at a change of 2. So that's plus 2. 4 to 6 is 2. 6 to 8 is 2. But then it's 8 to 0. That doesn't make sense. That's a minus 8. So just from that, I know that this is not proportional because those numbers don't go up or down by the same amount every time. I could have also seen the 2 zeros not next to each other. So since this 0 is matched up with a 2, that 1 is matched up with our 0 on the other side, I know that's not proportional from that as well. So whatever you saw first, I really don't care. You write no and then whatever you see. The zeros don't go with each other, which means that it doesn't go through the origin. Or it does not go up by the same amount, so it's not linear. Try this problem on your own, see if you can figure out if it is proportional or not, and I'll give you your answer in a second. And here's our answer. So it is not linear because I just started with my x's. It went from 6 to 2. So that is not the same number, which means that it's not linear. It's not going up at a constant rate. Okay, we're going to try a word problem together. This word problem is set up very, very similarly to what you would see on a test. So make sure that you understand each of the 4 questions that I'm asking and how to find that information every time. So I'm working through this problem with you so you get a better understanding of it. You're canoeing on Lake Monroe. You're paddling at a speed of 5 miles per hour. The distance y in miles is proportional to the x amount of hours that you paddle. If I'm going at a speed of 5 miles per hour, and I know that miles is y and x is the amount of hours, I'm writing an equation in the form y equals mx plus b. So I'm trying to determine, is my 5 my b, or is my 5 my m? Well, since it says the word per means multiplication. The only multiplication I see is right here. So that means that I have y equals 5x. Now there's not a b that I see because we aren't starting at a certain miles per hour or something weird like that that would cause us to add the b. So this is going to be our final answer. We're interpreting the slope. This question is just asking you, what is 5? It's right here. It's written in the problem. 5 is miles per hour. So I'm going to write mph. Create a table and a graph. So let me put in a table or a graph here. So now we have a table and graph. Let's use them. So just like before, I can select random x's. It doesn't really matter what it is. I like to do one negative, one positive, and have 0 in the middle. I'm just going to choose 1 and 1. So -1, 0, and +1. I'm taking those 3 x's and I'm substituting them into our equation. So 5 times x, or 5 times -1, is going to give me a -5. 5 times 0 is 0. 5 times 1 is 5. So now I'm going to take these 3 points and I'm going to graph them. So my first point is -1, -5. So start at 0, 0, go -1 on our x, -5 on our y. So that is our first point. Our next point is 0, 0, which is right here. And then our next point is 1, 5. So over 1, up 5. So now we can draw our line all the way through. Our last question is, how long would it take you to travel 26 miles? So we've got a y and we've got an x. I need to figure out which one I'm going to substitute 26 into. So if I'm talking about 26 miles, is miles my y or my x? Hopefully you said y because it tells you that it's miles right up there. So I'm looking at the equation that we created, and it's going to be 26 miles equals 5x. Now it's just a one-step equation. Draw my line. I see multiplication, so I'm doing division. And that tells me that x equals 26 over 5, which, if I am doing the math correctly in my head, is 5.2. And then the label is the amount of hours. So it's just 5.2 hours. And that is our final answer. It's clear. There we go. And now it's time for homework. So there's not too many homework problems. We've got 1, 2, 3, 4, 5, 6, 7. It's going to be on page 162. If you have any questions, please email me.